About Rolle's theorem and the mean value theorem. So we've had before two additional theorems that are very similar to the concept of the Rolle's and mean value theorem, and these are known as existence theorems, which basically, again, tell you, yeah, this is happening, but it doesn't tell you anything about it or how to find it, which is what I'm about to show you. Do you remember the other two theorems that we talked about? Say again? EVT. Yeah, EVT, that's the extreme value theorem, which actually we did in this unit. So that was the absolute min and the absolute max. And what about the other one? This was at the beginning of the year. Yeah, the IVT, nice job. And that was just the intermediate value theorem, which is not really what we're talking about here, but these were both existence theorems also. So I would recommend that you make sure. I think this is in your concept cards. Okay, so let's talk about the mean value theorem first. This is abbreviated as MVT, which you can use. Okay, so we're going to talk about the mean value theorem. And basically this theorem states that if you have a function that is continuous on a closed interval, okay, so that's one of the items that has to occur, and differentiable on the open interval, okay, then there is at least one point C in that open interval such that f prime of C is equal to f of B minus f of A over B minus A. Okay, so this is the first stipulation here, and this right here is the second stipulation that must be stated and verified. Okay, so this really isn't plain English, right? Like, I mean, if you didn't know, if you only knew a little bit about calculus, what is this? Forget about this part right here. What is this? Yeah, it's the slope of the secant line. So then what's this?
F prime of C.
Okay, what is it more specifically though? Thank you. The slope of the tangent line. So basically what we're looking for is where the slope of the tangent line is equal to the slope of the secant line. Guys, this is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? And then if you have the function, you take the derivative and evaluate it at that given value c. So here, this also says there's at least one point C. All we need to prove is there's at least one, but there could be more than one. So I'm going to show you two different scenarios. The first part that we need to make sure of is in our hypothesis, we need to be able to state that the first stipulation occurs, meaning that the function is continuous, and I'm just going to abbreviate because I don't have a whole lot of space here, on the closed interval from A to B. Okay, so here's my closed interval, right, from A to B. And what I'm looking at is the graph. Is the graph continuous from A to B? Meaning, here's my graph.
Yes.
Okay, and even though this is not a true way in terms of calculus to figure out if this function is continuous, would I have to pick up my pencil?
No.
No. Continuous. There's no breaks, right? No sharp points, no cusps. All right, and then the second part, okay, is that the function is differentiable on the open interval. So f is differentiable from A to B. Okay, meaning I can take the derivative here. So if you look, I could take the derivative everywhere here because on a continuous function, the only place that I wouldn't be able to if it was a graph would be a cusp or sharp point, right? Like the absolute value. Okay, so what they're saying is you have the slope of the tangent line, which would be here, right? And the slope of the secant line, which cuts through a curve. What they're saying is there is some point C on this graph where those slopes are equal. And here is your point C. So in this case, there's only one. Okay, but based on the theorem, they're saying that there could be multiple. So when we take a look at this next one, here we have our interval from A to B. We're verifying that the function f is continuous, yes or no?
Yeah.
Yes. Differentiable?
Yeah.
Yes. Okay, so now what we have is, here is my secant line that goes through the curve. So this right here is the slope, or the secant line. So we could find the slope of the secant line. Then we have our tangent line. And actually, in this case, we have two. So there's one, and there's the other. So here, this is the slope of the tangent line, slope of the tangent line. And what they're saying is, in this case, there's at least one point, but in our scenario here, there are 2 points where the slope of the secant line is equal to the slope of the tangent line. One of them is right here, and one of them is right here. Okay, there could be more, but this is on the given interval from A to B. Okay, questions? Okay, so this is pretty basic. My question here would probably be, how do we do it when we're given a problem, right? So, in the first example, it says verify that the hypothesis of the MVT would be satisfied on the given interval, and then if those conditions are satisfied, meaning the function is continuous over the given closed interval and differentiable over the given open interval, then I need to find the value or values of C that would satisfy the slope of the tangent line being equal to the slope of the secant line. So we need to find all those values. Now, when the question is stated like this, is it possible that there's only one? Yeah, you just have to see that your values fall in that interval. All right, so the first thing we need to do, and I'm going to put it here that you must state this, okay, your hypothesis. So in the first part of my hypothesis, we need to look at this function. So without this given interval, if I ask you if this function is continuous, without this given interval, is the function continuous? It's a yes or no question.
Yes.
No.
No, it's not.
Why? Okay, there's an x on the bottom, so what do I have graphically? You have an asymptote. So I said not on the given interval. Where is the asymptote? X is equal to 0. Now I give you the interval. Is the function continuous on the given interval? Yes. Okay, so what you need to look at is, number one, if this is a rational function, meaning whatever you are given, if you have vertical asymptotes, okay, you need to identify, is this function continuous on the interval? Meaning, what are my vertical asymptotes and do they fall in the interval? If they fall in that interval, then the function is not continuous and you have to stop. You cannot continue. Does everyone understand what I'm saying? So you have to verify that first. Okay, even if it's visual. So then what you state is f of x is continuous on the closed interval from 1 to 4. Okay. In the second part, if the function is continuous on that given interval, is it differentiable?
Not necessarily. Yes.
Well, it would be in this case because if you think about it, this is one of those graphs that kind of looks like this, and like the vertical asymptote's at 0, so you have a curve that goes this way and a curve that goes this way. So this is where you really need to know what your graphs look like, because you won't have a calculator. So the only thing that's really holding me up is the vertical asymptote, but it's not on the interval. So is the function continuous on the open interval, meaning not at the endpoints? Or excuse me, is it differentiable? I say continuous. If it's continuous, then it's differentiable on that interval. So the answer is yes. So you would state that f of x is differentiable on, and it would be the open interval. Folks, one thing you need to go back and look at, for those of you that are struggling with what I'm asking, is continuity and differentiability. You'd have to go back into Unit 3 and take a look at it, because you need to know how to find it and how to identify it. Okay, so remember, each unit is important for the next unit. So you can't, like in pre-calc or Algebra 2, you cannot forget this stuff. Okay, once you test it, you cannot purge your brain. It's not how it works. Okay, so I have stated my 2 pieces for my hypothesis, so now what I need to look at for my conclusion is, and I'm just showing you, I need to make sure that the slope of the secant line is equal to the slope of the tangent line. And if this is going to happen, I'm going to have a variable, so I'm going to have to solve. So we can find the slope of the secant line. Okay, so the slope of the secant line is going to be f of 4 minus f of 1 over 4 minus 1. How am I going to find these values? Plug them in. Okay, in the outlet? Oh, into f of x. Okay. So I'm going to plug 4 in up here. So when I plug in 4, this becomes 1. So what's f of 4? 5 minus 1 is 4. minus, when I plug in 1, what do I get? 1 over 4 minus 1. So what is the slope of the secant line, meaning the line that's cutting through the graph? It is 1. Okay, before I continue, does everyone understand what we just did? This is, what, Unit 1? I mean, we're just finding the slope. Okay, now, to find the slope of the tangent line, this is f prime of x. So I need to find f prime of x. So here we have f of x is equal to, am I boring you, Jay?
No.
Okay.
Not at all.
Thanks.
I'm just out here.
Check. So I want to rewrite this in friendly form. So this is 5 minus 4x to the negative first. That's just the function, that's not the derivative. So now f prime of x is equal to, what's the derivative of 5? 0. What's the derivative of negative 4x to the negative first? Take it slow. 4x to the negative second, so can I write it as 4 over x squared? Okay. So what we're saying is this is how we would find the slope of the tangent line, agree? Now more specifically, we would have to say find the slope of the tangent line where x is equal to blah, but we don't know what that is. So what we now want to do is we have the slope of the secant line and the slope of the tangent line. We want to see where, if on that interval, those two will be equal to each other. So we set the slope of the tangent line, okay, 4 over x squared, equal to the slope of the secant line, which is 1. Okay, so you know how in the theorem it says there is at least one value c, like the letter c? Basically what they do is they just change that x to a c. It doesn't matter. We're looking for where on that interval from, in this case, 1 to 4, which is going to be on my x-axis. They just use a different letter to represent it. Does that make sense? Okay, so this is essentially 1 over 1. If I have a variable in the bottom, and I need to solve for x, you cross-multiply when you have a single fraction equal to a single fraction. Do you guys remember that? Okay, so now what we have is x squared is equal to 4. I'm going to take the square root. So I get how many answers here?
2.
I do. I get x is equal to positive 2 and negative 2. Now, it says, meaning the problem says, find the value or values of c that will satisfy the theorem in the interval. What's the problem? Negative 2 is not in the interval. So your answer is positive 2. So if you give it to me as x is equal to 2, I'll take it. If it's multiple choice, you might see it as the letter c is equal to 2, and it's based on the fact that they talk about that c value in the theorem. Either one is sufficient. Everybody okay? Questions on how you find it? Are you sure? Okay, so the biggest piece here that you need to take away is that when you are using the theorem, you need to know what it states. If you don't know what it states, it's not going to help you.